Hi everyone, I am Dr. RajeevKumarP. Welcome to my YouTube channel. Today I am going to discuss with you a numerical problem related to permeability of soils. The numerical problem given to you is this one. A permeameter of diameter 75 mm contains a column of fine sand 500 mm long. When water flows through under constant head at the rate of 200 into 10 cube millimeter cube in 60 seconds, the loss head between 2 points 250 millimeter apart is 375 millimeter. Determine the coefficient of permeability. Next set is if a falling head, that is variable head test, is made on the same soil sample using a standpipe of diameter 30 mm. Estimate the time required for the water level in the standpipe to fall from 1600 to 1560 millimeter above the outflow level. So there are two sets of questions here. One is using constant head permeability test to be solved, and the another one is using the falling head test. So let us see how this can be done. Here you see the first arrangement is for constant head. You can see here water inlet here falling into a small tank, and soil is given in this area. So water flows through this and it is connected in a beaker or something. Okay, so then but always maintaining the head at this tank, so that's why it is called a falling head or constant head permeability apparatus. Okay, next one is this setup is schematic for falling head permeability test. In a standpipe water column, which is having water column, and with respect to time we have to measure the fall of water column from one point to another point. Okay, so we can measure H1 and H2, and all details of the specimen or the soil sample is given, thickness of the soil sample, area cross section, etc. Okay, so we can calculate directly from the equation related to coefficient of permeability for falling head permeability test. This photograph shows you the laboratory experimental setup. So this is useful for constant head permeability test as well as falling head permeability test. There is a chamber, glass chamber here, perspex cylinder, which is kept over here. This is filled with water, okay, for constant head permeability test, and the required parameters are noted down or observed. Okay, but here you see there are some standpipes here connected to a wooden plank here. You can see a graduated scale is also kept over here. So with respect to time, you can measure the fall of water level from one point to another point. Here, this one is the permeameter or permeability mold, okay, in which the soil is compacted to a certain density. Okay, it has inlet portions as well as outlet portions. You can see here. Okay, water by using the constant head permeability test, you can collect outlet. We can collect water through the outlet in a beaker. Okay, so here this one is the laboratory experimental setup. Let us see how this numerical can be solved. It has two portions. One is constant head permeability test, and another one is falling head permeability test. First, let us see constant head permeability test. And you know that it is given in the question the area of or the diameter of the permeability mold, okay, permeameter. So you can calculate. So for constant head permeability test, the coefficient of permeability can be calculated using this expression. K is equal to Q into L divided by H A. Okay, so this is the expression for coefficient of permeability for the constant head permeability test. Okay, this can be made in a box here. So you should remember this. This may be asked in the examinations and tests. Okay, in the given question, it is given that permeameter has diameter. Diameter is 75 millimeter. Okay, so we can calculate the area of cross section. Capital A, it is nothing but 5 by 4 into d square. D square is 75 square. So here you will get 4417.86 millimeter square. Okay, so we can directly, so other quantities are given, so we can directly substitute here and find out the coefficient of permeability. Q is given as 200 into 10 cube, and L, nothing but, it is given in the question, it is the points are 250 meter apart. So we are just considering only 250 millimeter. We are not considering 500 millimeter. Okay, that you must remember, because it is given in the question, the measurements are all taken for 250 millimeter thickness. Okay, it is given in the question, and here you can calculate, can substitute and convert the units. You will directly get 60 seconds is the time. $375 is the head difference, that 375 mm, and we have already calculated capital A, that is 4417.86. Okay, so I will mark here what are these parameters. This is T, time T, and this one is capital A, and 375 is the head loss, that is H. Okay, here the final answer for coefficient of permeability is, you will get 0.503 millimeter per second. So unit is always millimeter per second, centimeter per second, etc. Okay, you need to remember this. So this is the first set. So now we will move to the second set of question. Okay, now here the second part of the question is to find out the time required for fall of head from 1600 to 1560 mm. So in the variable head or falling head test, variable head test is also known as falling head test. Okay, we know that the equation corresponding to coefficient of permeability for falling head permeability test is 2.303 AL by AT into log H1 by H2 to the base 10. Okay, so this is the expression for coefficient of permeability for falling head permeability test. Here the cross section area of standpipe is to be measured, because you have seen in the first slide that how the experimental setups are kept. So small a is area of cross section of the standpipe. It is given in the question, the diameter is 30 millimeter. So we have to calculate this. So small a is nothing but 706.86 millimeter square. So this is the area cross section of the standpipe. Okay, so now in the question it is asked to estimate the time required for water level in the standpipe to fall from 1600 to 1560. Okay, so you need to calculate the time required for this test. Okay, so this is unknown here, so you need to calculate this. So already we have calculated the coefficient of permeability. The same soil sample is used for this test also, so the coefficient of permeability is constant. So here we substitute directly, we substitute all these things, we will get the answer. Okay, 0.503 is equal to 2.303. A is nothing but 706.86 into the length over which the flow takes place, or the we are considering only 250 millimeter as capital L. It is already given in the question. Okay, so this one divided by A is already calculated, that is nothing but 4417.86, and the unknown value, unknown is time. Okay, so here we have done. Then next quantity is log h1 by h2, that is 1600 divided by 1560 to the base 10. Okay, so here now you can calculate time, that is nothing but, after you substitute all these things, you will get 2.01 second. Okay, 4 seconds. Okay, so this is the answer for this numerical. Okay, similar questions you can expect in the examinations. All right.